I spoke last time about geologic maps, their importance, and a couple of prominent features of them, domes and basins, anticlines, synclines. But now let's talk about local geology. So here that you're looking at our Wisconsin geologic map, and as you see there, it's produced by our Geological and Natural History Survey, which is a part of the UW system as the UW extension. And we have three major parts to our geology. The part where we're talking and living right now, the southern and extreme eastern, extreme western southern parts are sedimentary rocks. And then the northern part consists of two different types of igneous and metamorphic rocks there. And so they have different patterns. But we're going to talk mostly about this lower sedimentary part because that's, again, the important part for this class. If we look at a larger geologic map, now this map, I'll enlarge it in the next slide, you see the two major Great Lakes here, Lake Superior, Lake Michigan. And so you see Michigan, Wisconsin, Minnesota, and Iowa in this map right here. You see different color patterns, again, reflecting the different rock types of different ages. And our geology in Wisconsin, we're a unique state. We have two prominent features here. We have both part of what's called the Michigan Basin to the extreme right, and then the Wisconsin Dome in our center here. So let's enlarge it. The Michigan Basin, you can see the rough outline of that. There's that bullseye shape. Remember that image of the basin that I showed before. And if you were to go to rocks in this area, the youngest rocks are in the center, this sort of light green pattern, and they get older progressively away. The rocks would all be dipping towards the center. And really, this is one reason why they have this big syncline here in Michigan. Michigan actually has an oil and gas industry because those type of rocks in that type of structure can hold petroleum. If you follow this out, sort of ignore Lake Michigan here for a second, just look, you see that this pattern in upper Michigan and into the UP extends down Door County, down towards Milwaukee, Racine, Kenosha, and then here's this pink pattern which kind of loops around in the UP, comes down and actually where we are, and then loops back up here. So part of Wisconsin is incorporated in this Michigan Basin. Then look, though, to the central part here where we have our igneous rocks. Notice it says Wisconsin Dome. Here the rocks are pushed up, and then the rocks sort of switch from being dipping towards this center here. When you look at them around this dome, they are all dipping outward. We don't have an oil and gas industry here because our rocks have been pushed up. The oil has vaporized out and it's preserved over here in Michigan. By contrast, in this central part of the dome, this is where a lot of our mining history is. So we have iron mines and other metal mines and things up here because that we're in this dome type center. So right here, locally, we see evidence of those things that we talked about hypothetically in the last lecture, domes and basins. But what about local geology? Let's talk about local geology a little bit closer. Well, this isn't local, obviously. This is Denio, Nevada, a little town in the middle of nowhere. If you look in the center part here, there's a line that says Oregon and Nevada. There's the border. This is all desert country, mountainous desert country, and this is easy to map geologically. I do a lot of my work up here, and you can just hike it and see the rocks everywhere. There's not a lot of soil on there. There's no pesky vegetation. Certainly there's very little agricultural work. You can see it over here. There's the town of Denio, if you can even call it a town. And you can see the fields where these people have irrigated them, mostly just to grow hay for the cattle that they let range over here. But my whole point being that geology is easy to map here. You can see it. You can see it with your eyes as you're standing on it. You can see it with satellites as you're looking down on it. Wisconsin's a little different. You know, our local countryside is covered with cornfields, bean fields, forests, soil, green stuff. But yet we can still map it. Here is a map of southern Wisconsin, part of it, so that's sort of arbitrarily cut off over here, but you can sort of see there's Illinois to the south, Wisconsin up here, here's Iowa and Minnesota, so this would be the Mississippi River, this area. There's La Crosse, I'm circling it. Madison would be over here, closer to home. Here's Beloit, Janesville, Milton, Jefferson, Watertown. So Whitewater, unfortunately, is just off the map right about where my cursor is going. Let's enlarge that a little bit. So again, remember, Whitewater would be right about here. Notice that the rocks around here are this sort of light blue lavendery pattern, and they're labeled as OS. Again, orient yourself by here's Beloit, Janesville, Milton, Fort Atkinson, Jefferson, Watertown. And so over here, pretty uniform, and then as you go a little bit to the west, it gets very, very complex, and really all these different patterns are showing you the places where we have hills and valleys and hills and valleys. This is our geologic map. These are the rocks that are here. And in particular, this one OS, it stands for Ordovician. That's why it's got the O. So boom, right away you know that we know the age of it from fossils. And it has been named and labeled officially the Sinope group. Sinope is a Native American name, and they just sort of chose that to designate this area where these natives lived for many, many years. The Ordovician Sinope group covers 25% of the state, but does it really cover it? This is a geologic map, so you might say, well, geology is exposed everywhere, just like Nevada. You know it's not. Let's look at a local political map. Here's a map how you normally think of a map. There's the outline of UW-Whitewater. Here is one highway, Highway 12. Here's another highway. Here's some rivers. So the Bark River, the Rock River, it names some towns, it names other roads. This is a political map. This shows human infrastructure with a little bit of nature on it. If we look at a satellite view of the same exact place, just flip your Google Earth so that you're showing satellite view, you still see the roads and stuff, but are you seeing any geology? No, I'm seeing a whole patchwork of farmers' fields and forested land. Basically, the geology is covered up. So how do we know about it? We know about it from several methods, but the prominent one is, look up here. So here's Whitewater, here's Fort Atkinson, there is County Road N and County Road M, and right there, that little white spot, if we enlarge it, it's a quarry. A place where we are actively digging in the ground to get a geologic resource. Now the geologic resource we're getting, let's enlarge it again. This is just turning on my three-dimensional view that you can do in Google Earth and look at it. What they're mining here, it's not that they're getting any kind of iron or gold or anything like that. They're mining this limestone. That's what this white rock is. And they are crushing it up. They crush it, crush it, crush it, and then they sell it for gravel to build roads. The going rate for gravel around here is about $7 a ton, and that means that any gravel that comes out of here, you only use it for local roads. If you drive it farther than a few miles, well, suddenly you're not making money on that $7 per ton. You've just spent $50 getting that truck to move down the road. So this explains why there are little quarries like this all over the state. Think about where you live. There's probably some quarry or several quarries inside your town, just outside your town, down the road, in the next town, because of the value of this product. We need this product to make limestone, gravel for roads. We need limestone to pulverize it up. It helps make cement and therefore concrete. it has a value. For me and for us in this class, what's important is that it is Ordovician in age and the Sinope group. It has strata that contain fossils that tell us about the age and the environment. So I typically take my students in my advanced classes, just because they're smaller classes. I take them in several, and we go and collect in these quarries to do local geology, which again, as shown in this cartoon here, all geology begins with collecting rocks and fossils outdoors and then mapping that or adding it to existing maps. Now the next few slides are just showing you some pictures inside one of these quarries. Here's the outside of the Howes Brothers quarry. Here I am with a bunch of students. We have to wear hard hats in there to do this, and you can see the walls of rock here, and we can sample the rocks here, and you find a whole bunch of things. I've shown these pictures before, but now you understand terms like shallow marine, EOD, environment of deposition, paleoecology terms like colonial, benthic, carnivore, immobile. Here's a coral. So now we know the age of this rock, we know what it eats, we know the environment, and paleontologically, know the name of this thing. Here's another one, Trepospira and Prassopora. These are bryozoans. Again, shallow marine, solitary, immobile, benthic, epifaunal, suspension feeding, all those things that we just learned about in the paleoecology context. Orthus is a brachiopod. We talked about those as being around at the very start of the Cambrian. Here they are still thriving in the Ordovician. Endocerus, we haven't talked about these yet, but this is a huge voracious carnivore. You see it's a couple feet here right beside my hand, but it would be several feet more on either end. This becomes one of the large predators of the day. And then, of course, snails. My finger by a little teeny tiny snail. This is Lophospira, and here's all of its relevant stats. Here's another quarry closer nearby. This is the Whitewater limestone quarry. This is actually within the city limits of Whitewater. What you're looking at here, the highway crossing the bottom half is Highway 12, and as you go from left to right, you are heading towards Elkhorn, Lake Geneva, and Illinois this way. So as you're doing that, this is the big quarry you see off to your left. The vertical road you see here is Franklin Street, and really just less than a mile up this road is Whitewater, UW-Whitewater campus, all that. So you can walk to this quarry. We go in this quarry quite a bit too. Here I've gone to the Google Earth 3D image view. You can see the walls of the quarry, some of the active roads and things in here. And again, you go there, you sample it. What is it? It is Ordovician in age based on the fossils. It is the Sinope group. And so I know that that OS rock type continues across these parts. This is how we start making our map. Here's some pictures here. There's the sign on the outside, Whitewater limestone. Here I am in the pit, and you see several people, students, up here collecting the fossils. And you get all those same things from the other ones, but I'm going to show you a couple of different ones. This is Receptaculites, this weird thing that I'm holding in my hand here. And this is a fossil algae. And so this is a producer. It's a plant. It's a photosynthesizing thing. It's one of the things at the base of the food webs in this area. And we still have trilobites. There's my finger and a weak impression. It's not a great fossil, but here's an impression of a trilobite. They are shallow, marine, solitary, all these things. Incidentally, they're also the Wisconsin state fossil, as shown on this patch. Crinoids, it's kind of hard to tell what this is and see it here. You're probably just looking at it and seeing some weird lines. Again, if you do paleontology or take the paleontology course, you would learn these things. Here's another picture. There's my hammer point for scale, and you see this long stem that this thing would be on. Crinoids. Well, collecting fossils in quarries, allows us to do mapping. There's other things that help us do mapping, and these are cores, excuse me. If we go to any river edge, we can see rocks. We have the quarries, but also drilling. In a state like Wisconsin, where we're covered by the dirt, the soil that grows our crops, we have to do these cores to know about the geology below. And in Wisconsin, these things are stored in a huge warehouse in Mount Horeb. You are looking at just one small part of the core repository, the core library, if you will, of the Wisconsin Geological and Natural History Survey. And we save these things like a library. They are archived forever so that we know what's going on in the subsurface in all these places. Why we do this is because when we want to drill for water wells, when we want to drill to find different resources, maybe somebody drilled a core up near Bayfield 50 years ago, and they examined it. They're now examining it today, and they find, there's iron ore there. We can start an iron mine there. These things help us do resources. And I've taken students, they do nice tours for geology students here to see the core repository and how they do things. Doing these cores everywhere then allows us to see a more complete slice into the earth. We call these slices into the earth a cross section. So this looks like a slice through a very sloppily made cake, but you sort of see the layer cake structure here, flat beds, just as Steno said they were, a little bit of alteration away from horizontal, but you see the geology of our area of Wisconsin. Remember, here's this upper OS pattern, and remember that covers large parts of where we are. And where are we here? So if you look, this is going from south to north, and you can see in really little type here, Beloit is on the extreme left. There's Janesville. They were heading north. There's Milton. Here's Fort Atkinson. Here's Jefferson. Here's Watertown. This Q is the rock type that's right at the surface. So if you could walk this, you'd be walking right here on this Q, and all you would see, notice there's no place until you're well north of Watertown where you actually see any of this rock below. This Q, what is it? Q is what I call overburden. It's basically dirt. The glaciers from the last ice age plowed down here, they melted away, they dumped all this dirt, which makes our wonderful soils. We have some of the best soils in the world. Think about what you have from Beloit to Watertown. Think of all the corn and bean crops and everything that grow here. That's this Q. So I don't want to say that this is worthless stuff. It's very valuable for agriculture. But for a guy like me, a geologist, I want the stuff that's below. And notice it's all not exposed, except cores, where people have drilled these cores. And then, notice there's a few places where the rock is right near the surface. Those are the best places to dig and make your quarries. You might have wondered, well, why do I have a quarry here and not right over there? Why can't they make a quarry on my property and make a lot of money for me? Because we want places where this rock is exposed near the surface so we don't have to pay a lot of money to dig down and get it in the subsurface. And this weird irregular pattern that the rocks have below this Q is due to the glaciers scraping over them and plowing out giant sort of little valleys and rifts where these are exposed differently here. And then a very, very local cross section again. The Q, we plant our agricultural products on it. The OS, we dig down and have quarries here to get our road building materials. But lower still, these Cambrian formations, labeled as C with a line in it down here, they're all in the subsurface. We don't do anything with them. Farther north, they're near the surface, and they are quarried for sand resources. Mostly for what we use these maps here around here is to tell a water well driller how far down do you have to drill to get to some of these units like the CS, the OP, the CT, to get to a source where you can have a water well.